Hey, this is Steven from LegitTechTutorials and welcome back to my product design series. We are back working on the plasma table. This is video number 5, I think. Like that? 5? Yep, video number 5. So we're going to be back working on the gantry. Finishing up, putting all the bearings in here that need to be put in here, and then put in the side plates. And we put in the side pieces that also have the bearings that need to go in there. And then with that, we should be good on this. Duplicate it, put it on the other side, attach it to this other assembly here. And yeah, so put this guy on here. Put this bearing on here, put the bearing across here, figure out how we're going to attach the other one, probably just weld it across here, get it nice and square, square it up. Yeah, let's get it nice and square, and this guy would be welded across or bolted or whatever. So we could take it apart. Again, this is, for right now, this is assuming that we are not going to, no, we're not going to bolt anything. It's all just going to be welded together, single one piece. I mean, obviously you could take this off if you just roll this thing off the side. It'll come off. Okay, so let's go ahead and put the other bearing in here. Roll this over here. Say OK. Let's go ahead and joint it. It's a revolute. You get the idea. There we go. These guys go on there like that. Okay. Now we need the holes cut in the side. The main problem is that this is referenced from another piece. So you can actually cut the holes in the side on this one. But what we'll do is we'll do this, and then maybe off screen I'll cut it on the actual one. Okay. So we need to go from here to here. Find the center line, midpoint. Okay, it's perpendicular. Alright, then let's do same distance. Come down from the center of this bad boy. It's not going to let me do the center. I need to project. There we go. Okay. Also this guy, construction line. Project, include this next guy. Good. Okay. So that's projected. Now this has got to have a hole at least 22 millimeters in width here. So this would be 22 millimeters tall and at least 8 millimeters wide. It's not letting me enter that in because I hit tab. 608 ZZ bolt bearings, which I have a whole bunch of now, plenty enough to make this machine. So board diameter 8 millimeters, 22 width 7. So let's make this 8. Uh-oh. Is that still in the center point? Yes, it is. Looks like it's moving. It is moving. There it goes. Okay. So basically like that. And then the bearing will pop through. Then be, what was it? It's going to be 22. So the next question is, so the distance from here to here is 9 millimeters. 9 and some change. Okay, 9 millimeters. So let's just attach the bearings up here just to get a sanity check of this thing. Go. Okay. So this guy needs to go through, but yet this piece still needs to be here. So this might need to have a piece come through here. But where? I guess that could work. I mean, is it touching? It's not touching yet. Okay, so where are we? Pretty much right in the center. Yeah, this thing is perfectly lined up. Okay. Okay, so what I'm thinking about this is that there will be a rod that goes through there like this. So we'll get a small little 1/8 inch rod. Put the bearing in there. Place it inside this piece so these guys are hitting. and then weld it in there, and then that bearing is pretty much going to be stuck for the most part. And put a little piece of wood or something right here so it doesn't touch. And so just the outside spins. Inside stays still. Okay, so I do like this. This looks really good. This is pretty much right where I need it to be. But with the 608s, unless I get a lot bigger ones, I have to be just as I have it. So if that's the case, that means that we'll have to go here, edit sketch, center point rectangle. This is going to be at least 8 millimeters wide. So that's both going to be a hole. Oops. So a rod is going to go in through here. It's going to attach. I'm going to weld it in there so it doesn't move. And then if we want, I'm probably just going to weld it in there. And if we want to fix the carriage, if one of the bearings goes bad, we're just going to have to just make an undercarriage, pretty much. Because this also, I want this to be a rod instead of bolts and thread, and just weld something, weld a little washer thing on there or something to keep this thing from moving. Weld it right in the center. After we push this guy in there using a drill press or using the mill to drill a perfect hole through there. As perfect as we can get it, of course. Copy paste. So this guy goes right in. That thing's almost right on. It's off by 0.5 millimeter. What about here to here, 1.525. Oops. So it actually needs to go back slightly. What? Okay, let's do a line from here. There. Dimension this. So 5 millimeters. So 0.5. Let's look at millimeters and see how much we're off. Millimeters to inches. And this one's off by 1.25, so it needs to go away. Actually, technically it only needs to go. Let's go ahead and pull that up. 1.65 minus 1.525. And then you gotta divide that by 2, because it needs to go this way, and then yeah. So it only needs to go this way. Needs to go to the left, 0.0625, and then this is gonna decrease by 0.625 plus 0.0625. That's about 2/1000ths of an inch. I'm good with that. You see here, 2/1000ths of an inch. Perfect. Okay. And obviously we could get that very different ways. So that looks good. So let's go ahead, take this guy, copy, paste, move this over. Somewhere there. Looks good. Alright, so there is our carriage. Okay, so now let's do the actual carriage. No. Circular reference not available. Maybe can I copy sketch or something? Copy. Right click. I made a mistake on that. Anyways, made a mistake on doing that, but that's okay. So I'll probably do that off screen, fix that. I won't let you guys sit through that, but let's do some let's do some analysis here. So let's say structural constraints. Let's just say this thing's not going to move. Let's do look at the DOF view. Do automatic contacts. It's probably going to say that there's internal, where stuff are attached to each other or whatever. That's okay. Oops. What's the other errors? Okay, so it doesn't say anything about it. Alright, so let's get that's good. Force, this face. Let's say this is, so this thing itself is 16 pounds. 16 pounds. Let's say 20 pounds. No, it's got to be more than that. Let's see. 20 pounds is probably about right. 20 pounds. Plus this carriage, I'm going to say around 25 pounds. Let's say 25 pounds divided by 2, one on this side, one on the other side. So that's 12.25. 25 pounds is 12.5. Yeah, this is by far going to... oh yeah, so I forgot another thing is to turn this back from acrylic. Oh, that was appearance, just to make it clear. Yeah, that's right, that's right. So these are all steel, whatever. Steel is steel, okay. So lovely salt. Okay. Oh yeah. So that's what we're looking for. I don't know about all that stuff, but say factor 15, deformation scale. Whoa. Okay. So what displacement are we looking at? Displacement 0.03 millimeters, which is 0.03 millimeters. 0.003393 millimeters, which is about 1/10 of a thou. 0.000133. Oops. Okay, I'm happy with that. And attached here to the bearing, obviously these two bearings are not in the same spot, but you get the idea. Okay, so now another one. What about if I added a second load at this edge? Let's say angle. Of 15 pounds, let's say 15 pounds, yeah. So let's just say that it's going really fast, it goes over this way, hits here. So let's say that the gantry itself is 5 pounds. So that's 3 meters, that's 3 feet per second acceleration, right? Slugs, right? Slug, ton of them. Yeah. So let's do some analysis on here and see what we can get. Okay. A lot of force right there, obviously. Displacement. Maximum's right there, 0.01. Interesting. That is still 0.04 thousandths. 0.04 thou. Okay, one last force. Edit structural load. Let's put this force where it probably is most likely to be, which is on this face. Let's run that locally. Then one more thing that I want to see is when I put it on the bottom. Okay, we're looking at displacement. 0.006, which is 0.3 thou, which is really small. You'd have very good calipers to measure that. Okay, it looks good. I like it. Safety factor max 1%. It's a good stress. Any sort of concentrations in some of the corners, and for whatever reason it really likes that bearing there. I don't know why, but yeah, obviously in the bearings are the contact point. Oh, and also it's attached here, so I mean this is probably not really the best because it thinks it's attached here because it's going right through it. But so yeah, technically this is not the best test then. So another one that I want to try is to put it on the bottom of this face. See how much it deforms the top. Another thing I could do is I cut the bottom out of that. On the other picture. Okay, displacement. There's 0. A little bit of displacement, but that's 0.02 here. 0.002, which is really small. Okay, so let's go ahead and close this. Let's go ahead and go to this one. And what I'm going to do is I'm going to look at okay, so this is the front. So I need to cut it out of the bottom. So you have front, back. Let's cut it out of here. Okay. Then I'm going to go to the back side here. Project include, project this piece. Go to the back. Shoot it outwards, cut it. There you go. And then let's go ahead and save. Now, should please do not crash. Not crash. There we go. Alright. So this should hold it together. This probably definitely needs to be welded because we need to hold this thing together because it's not going to have that much integrity. Let's go to simulation. Let's run the simulation again, see what we get. Result view. Okay, so now we are definitely a little bit more red here. So it's definitely not as strong as it was before. So now this is 0.00115, which is 0.0004, so that's 0.4 thousandths of an inch. Yeah, 439 thousandths of an inch. Okay, so that's looking good. I mean, I don't really understand how this other part here, where's my probe? This is very small. Very small. Very small. Most of it's very small. I think this is going to work great. Oh, let's do my probe here. Surface probe. This is moving 0.0024. 0.0024, which is very, very small. This is even smaller. Okay, let's go ahead and pump up the deformation scale to adjust it in half. A little more deform so you can kind of see what we're looking at. Okay, so it's going to twist. So we're pushing this way, so it's going to start to twist. Okay. I wish there was a smaller deformation scale, because we're probably not even going to be able to see it. Yeah, it doesn't even move. You can sort of see the movement line. It's pretty stable. Okay, so this is the design we're going to go with for the gantry. Off camera, I'm going to put it, change this piece to have all these holes cut in so we can later assemble it. Alright, so this has been Steven from LegitTechTutorials. I'd like to thank you guys for watching. If you like this video, please subscribe for more videos like in this series and other series like it. I'll talk to you guys in the next video. Thanks for watching. Take it easy. Peace.